Hello, dear. Good morning. Yes, welcome to Physics Made Simple with Sir Idria. Yes, this is the maiden edition of this online tutorials or teaching in physics. And I hope or I entreat you to please subscribe, share, and then pass your comment for as a feedback mechanism so that I can do this better for us all. Thanks so much for your support, and I believe you are going to share, you are going to subscribe, share, and then pass your comment. Okay, for modifying the whole system so well for us all. Thank you so much. Once again, the link is Idia. If you go on YouTube, just type Eric Idia, and all my videos will just pop up for you to have an exciting experience in physics. Thank you so much. Today I'm going to begin with you the concept of simple harmonic motion. Simple harmonic motion, also known as SHM. Why the name simple? These are just fanciful words, so interesting. Simple harmonic motion, but these are stuffs or kind of motions that takes place around us every day. It happens every day in objects, in machinery, and so on and so forth. So we are going to study the concept of simple harmonic motion and how it relates or applies to to the human life or society. Okay, so let's begin with SHM. But before we look at SHM, simple harmonic motion, I want us to look at a major concept, periodic motion, and then we look at oscillatory motion. Then we narrow it down to the our concept of interest, the simple harmonic motion. So what is periodic motion? Okay, the word periodic, okay, comes from the root word period, and period, as we often use, is an indication of time. Okay, now when we talk about periodic motion, we are talking about the kind of motion which takes place within a fixed time interval. So the motion is executed by bodies, particles, okay, any mass, objects, and so on and so forth. But in the body's quest to execute such a motion, this kind of motion takes place within a fixed time interval. And a typical example of periodic motion is the motion of the earth around the sun, okay, or the revolution of the earth around the sun. You know, the earth takes as much as 365 days to make one complete revolution around the sun, and after that the motion is repeated. So the body goes through the same motion again. At every 365 days it has made one complete revolution. Then the same path is taken over and over again, okay, within the same time interval of 365 days. And this kind of motion we say is a kind of periodic motion, because the motion takes place within the same time interval. Another example of periodic motion can be the rotation of the hour hand, the minute hand, and then the second hand of the clock. Starting from 12, okay, through having 1, 2, blah 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 blah, back to 12, one complete revolution. Okay, then the same part is repeated, motion is repeated on and on and on and on. So in each complete rotation, the same fixed time period is used in every one complete revolution. Is that okay? So any motion which takes place within a fixed time interval, the motion is repeated. The mass or the body goes through the same distance at every rotation or repetition is said to be periodic. Yes, having explained the concept of periodic motion, and then with the two examples, I want you to look around, open your eyes, because as I said earlier, this kind of motion takes place within the society. Okay, so open your eyes and brainstorm to get more examples of periodic motion. Okay, so quick one about the definition, and then so we said that periodic motion, that is the type of motion of a body or a particle which takes place within a fixed time interval. So the type of motion of a body or a particle which takes place within a fixed time interval. An example is the motion of the earth, of the planet earth, around the sun. 2, the motion of the hour, minute, second hand of the clock. Then we also have the motion of a simple pendulum, etc., etc. All right, good. So this is periodic motion. Now let's also look at what is oscillatory motion. Oscillatory motion, or to oscillate, oscillatory motion. Yes, oscillatory motion is another kind of periodic motion. All oscillatory motions are periodic motion. Okay, now in oscillatory motion we always have the repeated up and down motion of a body, or to and fro motion of a body around a fixed point. Okay, so the repetitive back and forth or to and fro motion of a body around a fixed point, okay, is what we call as oscillatory motion. And a typical example is this. Look at this arrangement. This arrangement in my hand. This is what we call as the simple pendulum. A simple pendulum is any mass connected to a string and then tied to a fixed point or a rigid position and made to undergo or made to oscillate. Okay, so this is a simple pendulum. This is the mass, this is the string. Okay, if I connect one end of the string to a fixed point where movements around which movement can take place, I have a simple pendulum. Now, if I cause a displacement of the object in one direction and leave it, you will see the repeated back and forth motion of the mass or of the body around a fixed point, an imaginary fixed point. So yes, this is the as at when the body is still immobile, we say that this is the equilibrium position of the object. And it is the equilibrium position because at equilibrium, the net force acting on the body is equal to 0. So at this position, the net force acting on this body is equal to 0. That is why the body is motionless, not moving in any direction. Okay. Now, if I apply a force to the object in one direction, the object moves in the direction or accelerates in the direction of the force. So if I displace it in this direction and leave it here, we will not see the object being still, but will be moving, okay, oscillating. Okay, so that is why at this virtually standstill position, we say the object is at the equilibrium position. Is that okay? So at the state of equilibrium, we have that fixed point or equilibrium point. Okay, now when we apply force to the object in any direction, the object will accelerate in the direction of, okay, and here we say the object is oscillating. Sometimes we also use the word vibration, but the word vibration is used when the oscillation is so fast. Okay, then we say there's a vibration. But vibration is also an oscillation. But the difference is that vibration is usually so fast. Is that okay? All right. So any body or mass, okay, that undergoes a repeated to and fro or back and forth motion around a fixed point or around an equilibrium position is what we call as oscillatory motion. All right, so the definition. So this is the repeated to and fro motion of a body or a particle around a fixed point or an equilibrium position is what we call as oscillatory motion. So this is the repeated to and fro motion of a body or a particle around a fixed point or an equilibrium position. Okay, so let's assume this is a fixed point. Let's look at the simple pendulum. As at when the object is at standstill, we say it is at the fixed point or the equilibrium position. Now when net force is applied in one direction, the object moves from this point. Okay, so it moves from here to this point. So this is 2. Then it will also move from here. So from here to this point. Okay, then from this point to another point. So from here to this point, then from here to this point as well. But because the object has inertia and so has momentum, it will come to this extreme. Okay, so from here to this point, okay, from this point to this point, okay, from this point to this point, from this point to this point. So we have two in one direction and fro from. The fro actually means from. So we have to and fro, to and fro, to and fro. Or sometimes the motion can also be up and down. Okay, example, a loaded spring. If we have this, there is a spring. When you load the spring with weight and then cause the stretching or compression, when the spring is either compressed or stretched and left, you see it moving up and down. Okay, okay, um displaying this kind of oscillatory motion. So oscillatory motion can either be to and fro, or the up and down or back and forth motion of a body around a fixed point or equilibrium position. All right. Okay, so let's look at some examples of oscillatory motion, which is also periodic. The mother concept is periodic motion. So examples of oscillatory motion. One, so okay, examples. We have one, the motion of a simple pendulum. Yes, and I showed you what a simple pendulum is. This is an example of a simple pendulum. Okay, any mass or a body connected to by a string and made to oscillate. So in our laboratories or in our schools, we have the metal shot. Okay, and that's the mass. Then we often tie a string thread of known length to it, and then we often tie it to the rotor stand and made to oscillate. So this is a simple pendulum. Okay, it isn't any astronomical or foreign kind of thing. You can make your own simple pendulum. Then we have the motion to the motion of a compound pendulum. Okay, a compound pendulum is also just a metal rule with equal interval, space, distance within, and then made to oscillate on a rotor stand. Okay, yes, the name sometimes sounds so fanciful, but they are very so simple stuffs which can be found within the environment or in the laboratory. We also have the motion of a loaded spring. The motion of a loaded or weighted spring. So when you attach a load to the spring, okay, we have a loaded or weighted spring. So if this is the fixed point of the spring, this is the spring itself. When we attach a load to this is what we call as a loaded or weighted spring. Now, as I said earlier, when the spring is stretched or compressed, okay, yes, certain work will be done, and the work done is stored within as elastic potential energy, and that is what causes the work done in stretching or compressing it is what is shown in the up and down motion of the spring. Is that okay? So the motion of a loaded spring is an example of oscillatory motion. Then we also have the motion of a bifellar suspension. And this is another simple system, okay, that can always be demonstrated in the laboratory. Okay, so with a bifellar suspension, we have two rotor stand. Okay, each rotor stand is connected to by a string. Okay, then so let's assume these are the two rotor stands. Okay, rotor stand 1, rotor stand 2. Then this is a meter rule, a string. Okay, and then a meter rule is connected to the two rotor stand, and when the meter rule is disturbed, okay, or made to move by holding the middle and then displacing it at small angle, you see that back and forth movement of this meter rule, okay, showing what we are calling as the oscillatory motion. So the motion of the bifellar suspension also is a form of oscillatory motion. Then we have another example, the motion of a cantilever. Okay, all right, so we have a lot of examples under oscillatory motion. Okay, so these are 5 of them. Let's look around. Please take note that in stating the examples, I was talking about what? The motion in all situations. Meaning that if you talk about simple pendulum and the simple pendulum is not made to move, the simple pendulum, the loaded spring, the bifellar is not made to move, you can't have that kind of oscillatory motion. So if you are asked to state an example of oscillatory motion and then you just write simple pendulum, you are wrong, because the simple pendulum has to move to show oscillatory motion. Is that okay? So please take note of the phrase attached to whatever we are talking about, the motion, so on and so forth. So this is it, okay? And the motion of these things also indicates a periodic kind of motion. All right, so all examples of oscillatory motion also suggest or connotes a periodic kind of motion. Let's take note of that too. All right, so now let's go on and look at our main concept, that is simple harmonic motion. Why the name simple? Why harmonic? They all have their very good reasons, which we'll look at. So simple harmonic motion, also known as SHM. Why simple? Because one, let me even define it before we look at the key stuffs within the concept. Simple harmonic motion is also a kind of oscillatory motion, but with some special attributes or qualities. So, just as oscillatory motion is the repeated to and fro motion of a body around a fixed point. So would be simple harmonic motion. Simple harmonic motion is the repeated to and fro motion of a body around a fixed point. But there are some qualities or attributes. What are the attributes? Here we say that the acceleration of the body is always directly proportional to the displacement of the body. Yes, we are talking about key terms here. The acceleration, as a physics student, you must know what acceleration is and displacement too is. Okay, so the acceleration of the body is directly proportional to the displacement of the body. Then the direction of the acceleration is always directed to the fixed point. Is always directed to the fixed point, or where we have the equilibrium position, meaning that the direction of the acceleration, the direction of the displacement are always opposite. Let me quickly demonstrate simple harmonic motion and then take key notes of the features, or take note of the key features within, for you to make meaning of SHM better. So this is a simple pendulum. Now look at it. At rest position, I have the body, the net force acting on the body being 0. That is why the body isn't moving. So a picture, this is where the rigid point, where the whole system is connected to an immovable point. This is the strength. This is the mass or the body. Okay. All right. So this is what I'm talking about. At this position, the body is fixed at a point. So fixed point. Now, if this body is made to oscillate, is displaced in one direction from the equilibrium position. Okay. From here, if we cause a displacement in the object through small angle, theta, the distance from this is smaller. Okay, the distance from the original fixed point to the new position of the object is what we call as the displacement. So this distance from here to this point is the displacement. Okay, and we often represent the displacement